Hello everyone, my name is Engineer Ali. I want to discuss a question on electrostatics. But in this kind of question, we want to look at a question that will lead us to triangle. We can solve questions that have to do with charges, but in a triangle. Specifically, we want to discuss equilateral triangle. An equilateral triangle is a triangle that has all sides equal. Now let's see. You see, three charges, Q1 3.7 microcoulombs, Q2 minus 3.7 microcoulombs, and Q3 plus 4.8 microcoulombs are fixed at the corners of the equilateral triangle. Now, equilateral triangle, 3 times 10 to the power minus 2 meter on a side. That means that the equilateral triangle has a side that is 3 times 10 to the power minus 2 meter as the side distance. Now let's draw the equilateral triangle. Let's follow up. This is equilateral triangle. So let's take this one as an equilateral triangle. And this equilateral triangle, let's see here, is equal to this place. Each of them is 60. Here is 60 degrees. Here is also 60. Here is also 60. And each of the triangle are 60. Now, the side that we are talking about now, each of these side, anything that we have here is still the same thing on what? On both sides. So that means if here is what? They say the side is 3 times 10 to the power minus 2. The side 3 times 10 to the power minus 2. We have another side again, 3 times 10 to the power minus 2, and so forth and so on. Now, they said what? 3 charges Q1. Let's say we place what? Q1 and on let's say this side. Let's put Q1 here. 3.7 microcoulombs. They now place Q what? This Q1. They will place Q2. Let's place Q2 here. Minus 3.7 microcoulomb. This 3.7 microcoulomb as Q2. Let's say our Q3 is 4.8 microcoulombs. That is plus 4.8 microcoulombs. Now this Q3. Now, what did they say we should do now? They said are fixed at the corners of the equilateral triangle. So what they say we should find the magnitude and direction of the net force on a charge Q3 due to the other charges. That means that we are going to do something here. Now watch. Now minus 3.7 microcoulombs is negative, plus 4.8 microcoulomb is also what? Positive. So what will happen is that they will attract. There will be an attraction. There will be an attraction here. This one also what? Attract. So there will be an attraction. Don't forget, they will attract each other. Now, but we are not interested in this one, so they forget about that one. Then this one says this one is positive, this one is negative. So what positive rather. Now, since it's positive, what influence will Q1 have on Q3? It will make it repair. It will repair along the line of action this way. It will repair. This one also what? Repair along the what? But we are not interested in this. So this one is cancelled. Because what we are asked to do, we have to follow the instruction. It said calculate the net force on Q3. So Q3 now, if you draw it, this angle is 120 degrees. That angle between is 120. This one is 120 degrees. Let's take note of that. Now, if that is 120 degrees, let's call this particular force between this and this. Let's call it F13, and let's call this one F. This one is Q2. So let's call it F12. So that means if you draw it out, what we are going to have is simply this. We are going to have a diagram of this kind. So this is what? the parallelogram, the forces that we want to have. So this is F12 and this is what? F13. So what the angle between them is 120 degree. Now, if the angle between them is 120, let's draw the resultant. The resultant will now be equal to a line drawn from the common point. This is the resultant. Now, let's complete the parallelogram. You have this like this, and we have this like this. So that is the parallelogram. Now, if you have the parallelogram, let us calculate F12. What is F12 now? F12 will now be solving what? K, Q1, Q2 over R12 square. Now, simply means that we are going to have it as well. K is 9 times 10 raised to power 9. That is between K1. Oh, sorry, this one should be what? This is 3, about 2 and 3. So that means this one should be 3, let's say 3, 2. Let's correct it to 3, 2. So this is 3, 2. So let's correct that one is 3, 2. This one is also 3 here. So in that case, if this one is 3 now, here also be what? 3, 2. That means we are calculating between this force, this Q2 and Q3. So we're going to have it as Q3 is 4.8 times 10 raised to the power of -6. Then what about what Q3 is Q3? What about Q2? Q2 is supposed to be what? -3.7 times 10 raised to the power -6. All divided by what is the distance apart? The distance between these is 3 times 10 raised to the power of -2 all square. Now, if you solve it, if you press your calculator, you can do that. You would have 177.6 Newton. That's what I would have for F3. Then what about F between this and this, which is what? F13. F13 is equal to what? Similarly, the same procedure. 10 raised by 9. Absolute of what? What is between 1 and 3? 1 is 3.7 times 10 raised by -6. Absolute of what about 2? I mean 3 is 1. So we are going to have 4.8 times 10 raised by what? So if you have gotten what about the distance apart? It's still 3 times 10 raised by what? -2 all square. So in that case, what we're going to have now is this. You are going to still have what? 177.6 Newton. Now, I haven't gotten the 2 now as the same 1.7 and 177.6. We'll now what? Write it here. This is 3, 2 and this is 1, 3. So that means this one is 177.6. Here is also what? 177.6. And don't forget, here will now be what? Corresponding to this place. This place is corresponding to this, which is 120. And here is what? 60. That means if you draw this angle out, this is what we brought out from here. Brought it out. This is 60. Then this one is corresponding to this one. This one is 60 balance, because angle on the straight line is 180 degree. So if angle on the straight line is 180, then the balance point here should be 60. Then there will now be what? Our resultant that we are looking for. So we have what? Here is parallel to this side. So it's 177.6 Newton. So similarly, what we'll just do is to what? Take the resultant. R square equal to 177.6 square plus 177.6. I'm using parallelogram law. The two sides, these are the two that one included angle. What is the angle there? Minus 2 into bracket 177.6. Instead of writing another 177.6, you can square it cos 60 degree. You know why? Because you have to see the same thing as 2 times 177.6 times 177.6. Instead of writing, just square it like that so that you have our this in there. Now, if you do that squarely, what we are going to have is that this one will give us 0.5. 0.5 times 2 will give us 1. 1 times 6 will give us that. Then 177.6 now. Now we have 177.6 square plus 177.6 square. Then minus 177.6 is equal to r square. So what we are r square? This one will cancel this one. So our r equals to what? Square root of 177.6. So square. We are going to have our answer. Why? Because you want to make r the subject of formula. You take square root of both sides. So we are going to have 177.6 as a resultant. Now another thing again, after solving that, what to do now is to find the direction. We have gotten our what? Our resultant. To find direction, what we are going to do now is that we are going to now use what? Sine rule. That means this one now is facing this angle, so it becomes what? R over sine 60 degree. Don't forget, using sine rule, this side is facing this side. Then what again? This direction we are looking for, alpha, according to parallelogram, is facing this side. So this one will be what? 177.6 divided by what? Sine alpha. Don't forget our r equal to 177.6. So if you do that, cross multiply, you want to have sine alpha is equals to cross multiply, then divide this in or times r equals to what? 177.6 times what? Sine 60. So divide both side by r. This one will cancel this one. What we have is sine alpha equals to what? Divide both side by r. So 177.6 sine 60. 177.6 times sine 60 divide by 177.6. Now if you do that correctly well, now if you do that, what we are going to have is that we are going to solve it, and what we have is you cancel out. So this one will cancel this and this. If you do it, then what we are having now, because we are making sine alpha, which is direction of the resultant, the subject of formula. So alpha become, take sine inverse of sine 60 degree. If you take sine inverse of sine 60 degree, what we are going to have is 60 degree as the alpha. So therefore our answer now, our answer is the resultant is approximately 178 Newton from here to the what? To whole number. If we convert it to whole number, then this one will not be what? Direction of 60 degree. So this is our answer for what? For the resultant and the what? The direction of a triangular what? Electrostatic what? Force. Now I hope you have enjoyed the video. Please subscribe and press the notification button. God bless you. I am Engineer Holiday, aka the Shortcut Master. Please ensure you share the video with others so that they can be aware of us. Thank you.